To start 5-1, we need to just talk about some basic vocab words. These vocab words aren't just useful for Chapter 5, but they're useful for all of your math classes in general. Some of them you've probably heard before. Monomial, that's describing an expression. What does the word mono make you think?
One.
So a monomial is an expression with one term. What does the word poly make you think of, or the prefix poly? Linny?
Expression with many terms.
There you go.
A parrot.
What do you call a dead parrot? Polygon. What do you call a hungry parrot?
Nobody cares.
Polynomial.
What?
Polynomial. Ha ha.
It's no meal.
I know. You have to use your imagination. It's a joke.
I have no imagination.
Okay. All right, now we've used the word term twice here, but we haven't defined it. A term is just a number, or a variable, or the product of a number and variable.
What does it say?
I can move it after I type it. There you go. So a number, you guys all know what a number is. Give me a number.
2.
7.
731.
I heard 7. 7 is a term. Okay, 7 is a term. Give me a variable.
X.
Okay, x is a variable, or the product of a number and variable, 7x, or 3n, or anything you could think of that's a number and a variable. Degree. When we are talking about the degree of a polynomial, we are talking about its highest exponent value. I should just say exponent. It doesn't need to say exponents. What do you guys think of when you hear the word degree?
Temperature.
Okay. Now, this really has nothing to do as far as the two being related, but it might help you remember that in math, when we're dealing with the degree, we're talking about the exponent. Because you guys know that exponents are set up in like a superscript. They're set above the number, right?
Right.
Think about if you were writing the temperature outside. I don't know, maybe it's 28 degrees outside. Your degree symbol is superset. It's up there. It's made a little bit above the numbers, just like your exponents are above the numbers. Maybe that'll help you remember that degree is the exponent. Think about the degree symbol. That's in the place of where an exponent would be too. Really, they are not related, but that's just a helpful way to remember it. Now, numbers 1 through 4, the vocab words there, that's what we're going to be talking about today. We'll go over the other two, but we won't get to those until next week. 5 and 6 are talking about different parts of the graph and different things dealing with the graph. So we have a turning point. A turning point is a point on a graph where the graph changes from increasing to decreasing, or vice versa. So let's think about if we had this shape on a graph. If we started over here, we would be increasing, increasing, increasing. And then we would get to a point where we're no longer increasing and now we're decreasing, decreasing, decreasing. But then we'd get to another point where we would start to increase again. Those points are your turning points, where the graph changes from increasing or decreasing. And then the last vocab word that we have is end behavior. The end behavior is just describing the graph. It's saying what the graph is doing from left to right. So if we would look at this graph, from left to right, my arrow is pointing down, then it is pointing up. So the end behavior would be down, up. We're going to talk about that next week, but the end behavior just describes the direction of the graph from left to right. We talked about quadratics pretty much all of chapter 4. And we always use this word, quadratic, quadratic, quadratic. What does quadratic mean? It means it's to what power? Did we deal with stuff to the 4th power in chapter 4? No. To the 2nd power. Yeah, almost everything we dealt with in chapter 4 was to the 2nd power. That's what quadratic means. It means to the 2nd power. And we're going to be naming things today, such as quadratics. But before you name something, you have to make sure it is in standard form. So the standard form of a polynomial arranges the term by degree in descending numerical order. It arranges it by degree. We know degree means exponent. So it arranges it by the exponents in descending numerical order. What does that mean? Descending numerical order. What does that mean? Kyra? Yeah. And right there, they have a polynomial listed for you. 4x to the 3rd plus 3x squared plus 5x minus 2. As you can see, we start with the cubed value. That's the highest exponent. Then we go to the squared, to just an x, and then we go to the number. Think about whenever we were doing standard form of a quadratic. We had y equals ax squared plus bx plus c. That c was always just a number. And we call our just a number a constant. And then we have other names, linear, quadratic, cubic, and we name them based on their exponent. And this chart on the next page describes that more specifically. In the middle, we've got our examples of the polynomials. Then we have a name using its degree. Degree just means what? The degree is the exponent, right? And then we name them according to the number of terms. So when we have a degree 0 exponent, or a degree 0 polynomial, that means I would have something like x to the 0 power. But x to the 0 power is never written like that because it's just 1. So nobody writes that. Nobody writes to the 0 power. You just write the number. So when you just have a number, it is called a constant. It is degree 0, and you call it a constant. So when you just have a number, it's called a constant. In that example, x plus 4, that x is to what power? Right here, this x plus 4. Lenny?
Is there such thing as a first power?
Yeah, there absolutely is. This is like x to the first power.
Are these all constants?
Nope. Whenever we have x to the first power, that also is not really written. It's just written as x, or whatever your variable is. But when you have something to the first power, it is called a linear polynomial. Now we have something, 4x squared. It is to the second power. What is something called that's to the second power? Quadratic, right? We already used that one. If something is to the third power, it is called cubic. Now notice there is a second power and there would be a first power, but you do not name them by those. You name your polynomial by the highest power. Anybody want to take a shot at 4? Think about $1. 4 quarters in $1. Degree 4 is called quartic. Degree 5, you can see our example there. The only exponent we pay attention to is the highest exponent. Anybody want to try 5? Think about babies. Think about 5 babies. Lilia? Yeah, it's quintic. 5 babies are quintuplets. Well, sorry. 5 babies are quintuplets because quin means 5. The prefix quin means 5. So, quintic is degree 5. Now, what if we have degree 6, 7, 8, and so on? They don't really get special names. We just go up to 5 whenever we're using these names. So if anything is above it, so I'm just going to use n to illustrate anything above 5. We just call it degree n. So degree 9 or degree 11 or whatever the degree might be. 5. Why do you guys think we call degree 0 a constant? Why do you think we call that a constant? Lenny?
Because 0 doesn't have like a value. It's always gonna be the same.
What's always going to be the same? You're right.
You take 0 and 5, it's always gonna be 5. 0 and 6 and 6.
Right, but we don't really need to use the 0 there. Think about your 5, or think about 6, or whatever number. We said that a constant is always a number.
Oh, it's always the same.
Yeah. It's constantly 5. No matter what, 5 is 5. There's not an x next to it that could change it. There's nothing added, subtracted, multiplied by it. 5 is just 5 all the time. A constant just means this is the number, and it's always that number. 5 can't be anything else other than 5. All right, and so those are using our degree. That's using our exponents. Now let's try to name these using the number of terms. Just one term was already in our vocab. What's a one-term expression? Meal. Think about your bike. What's a two-term polynomial? A binomial, right. Our next example, 4x squared, that's still only one term, so that is still also a monomial. Notice how different these monomials are. One of them is just a number. One of them is a number and an exponent. Still just one term, but they look different. But they're both still monomials. He's right. Is that what you're going to say, Lenny?
Yeah. I was gonna say.
Trinomial for 3, then 2x to the 4th plus 5x squared. That goes back to 2. A binomial. Now, 4 and above doesn't have any special name. We just call it a 4-term, or however many terms we have, 4-term polynomial. It would be a 5-term polynomial. If it was 10, it would be a 10-term polynomial. Remember, like we said right before this slide, in order to name these, they have to be first put into standard form, highest to lowest exponent. So things to remember about standard form. First, that you need to go to from the highest to the lowest exponent. Secondly, if you can combine like terms, you should. So look at problem 1a. We don't have any like terms there, but I'm going to reorder these to go from the highest exponent to the lowest. Your constant is always going to be last. If you have a constant, it will always be last. Now we need to name this. Look at the degree first. So you look at the highest exponent value, it's always going to be your first one because that's what it means to be in standard form. So your highest exponent value is 2. Degree 2 is a quadratic. And we also have to name it by term. So how many terms are here? 1, 2, 3. Good, Corey. It's a trinomial. Would anybody like to try B for me?
Oh, yeah.
Make sure you combine the like terms. Yeah?
Sure.
Lily's got her hand up.
Oh, I said sure.
Oh.
Are you kidding me?
Well, you didn't raise your hand. I'm sorry.
No, I got it.
Okay. Lilia, you got another one.
Alright. That's x to the fourth
Right?
plus 4x squared
Awesome.
plus 4x minus 12.
Good job. Just like Lenny did, combine the like terms. Maddie?
He combined like terms.
Why like terms? Come on, Maddie.
Who wants to name it?
Stop staring at me. I got it. No. Give it to Lily.
Or quartatic, or whatever you say that.
Quartic.
Quartic. Shut up.
How about by term? Do we have a special name for 4 terms?
4 terms.
Yep, it's just 4 term.
Term polynomial. It's not.
Who's doing the got it question? Got it A. Come on, guys. Somebody volunteer. Give me standard form. For got it, 1A. Maddie.
5x, 4, and then plus 3x, minus this.
Good job. Again, we have degree 4, so this is quartic.
Wait, whoa, why is that 4?
Because it's degree 4.
Oh, okay.
3 terms, trinomial.
Ismail, can you tell Andrew stop looking at me? It is
No,
making me.
Lenny's being really weird.
Lilia, do you want to try got it B since Lenny stole your last one?
That would be negative 4x to the fifth
Good.
plus 2x squared plus 13.
Very good. Just like she did, combine the like terms. And somebody else name this for me. Brennan? Good.